The topic of this lecture is dummy variables in regression. As you might know, in multiple regression, the dependent variable and independent variables must be continuous variables. In other words, the variables that are measured on at least interval or ratio scale. Of course, we have some variables that are measured on a nominal or ordinal scales. How do we incorporate these variables into the regression equation? In particular, when we have a nominal variable like gender, like race, this type of variable should be dummy coded. In other words, we have to use a dummy variable to represent these type of variables. A dummy variable is a variable has only two values, 0 or 1. If you look at the notes, in this case, you see you have x1 is a dummy variable because it has a value of 1 if the treatment A is used, 0 otherwise. Or x2 is 1 if the subject is male, 0 if the subject is female. There is another type of coding dummy variable, and one and negative 1. I'm going to talk about that later on in this type of dummy variable, but at this point, we concentrate on only coding dummy variable as 1 or 0. Back to our SPSS data set. In this SPSS data set, systolic blood pressures and age of the men and women are measured. So we view systolic blood pressure as a dependent variable, age as independent variable. And we have the gender, capital M stands for male and capital F for female. We're going to here run two regression equations, one for male and one for female. And in order to do that, I click on Analyze at the top, and regression, linear. I move the systolic blood pressure to the right as in a dependent variable box here. Age goes to independent variable. I highlight the gender and move it to that variable selection or selection variable. And as you see, you have equal and a question mark. We click on rule, and then come up with this value of these two categories we have. For the female, we use the capital F. So I use the exactly should be capital. If it's lowercase, should be lowercase because this is a case sensitive situation. So here is capital F. So capital F appears here. I click continue, and then click OK. And the output shows up here. I'm going to delete this part of the table right now. I don't need it. Only I'm going to concentrate on the coefficient table. In this regression, it's called unstandardized coefficient. We have the slope, which shows the change in systolic blood pressure for a 1 unit change in age. So in other words, as we get a year, or a female gets a year older, her systolic blood pressure goes up by 0.95, and that's known as a slope. And this one is an intercept, which is at age 0, you can say, at the starting, this is the systolic blood pressure. But of course, this doesn't make sense. The reason for that, because these are adults subjects, so we cannot really talk about the subject below 18 years old. But anyway, that's the line when the line intersects the y-axis, which is the systolic blood pressure, and that's 97 is a result. So again, as you see, we have gender equal female, and that's the equation. We can come up with the equation. It's called regression equation for female. I'm going to repeat that process and calculate or compute the regression equation for male. So I go to regression, linear, And this time, I only highlight that gender equal F and click on rule and change that F to capital M. And then continue and click OK. And then the new set of output will be the results. Again, I'm going to highlight each of these tables and then push delete. Only I come up with this coefficient. Again, this is a coefficient, our regression coefficient here. You see constant and age for male. All right. So you can plot that, and I've done that in the notes. If you go back a few pages down, and you see there are two lines for the male and female. So that's a line. As you see, this is a systolic blood pressure in a y-axis, age independent variable in a horizontal or x-axis, and then these are the two lines roughly, and this is the y-intercept. You know, when the line intersect that y-axis here, this is going to be 110. If this line intersects that y-axis, it's going to be 97. And then you have the slope. As you see, the slope for male is a little bit more than female. In other words, the rate of increase in systolic blood pressure among male is a little bit higher than female. All right. So that's we were able to generate these two equations, one for male, the other for female. Now we can do this. We can come up with the same equation, actually identical equation, but by running only one regression. In other words, regression one time, and this is happen, or this can occur by using a dummy variable. I'll show you how this is accomplished. Go back to the SPSS data set. Here is a gender is a nominal variable, has only two categories. We can come up with a dummy variable to represent this variable gender, which has only value of 1 or 0. So in order to do that, I click at the top, transform, recode into different variables. Then I click highlight gender, move it to the right. I have to come up with a new name for that dummy variable. I call it sex this time, sex, and then click change. So you have gender, arrow, sex, and then click on add and new values. So here in the old value, I type capital F. The new value becomes 1. I'm sorry, is capital. We use 0. The reason we do F because F in alphabetic is F prior to M. That's some computer program puts 0, 1, and some do it the other way. But as long as there are two distinct values, 0, 1 is fine. And also you know which one is which. So you have F female and 0, and then click add, and then capital M and 1, and then add, and then click continue, and then click OK. You see this new column shows up here. That's only this column only consists of 1 or 0. We're going to get rid of these, eliminate these two decimal places, and move the variable into center like these three other variables. So in order to do that, I click on variable view. You see you have the variable sex, in variable number 4. Now in the this decimal column, I go make it 0 here. Just this arrow up and down. You can make it up and up. The lowest is 0. We don't need any decimal for the dummy variable. Only has two values of 0 or 1. I click on here is center. Make it center. And always a dummy variable is a nominal variable. One other thing we can do here is helpful in the value column. I click on that and I click it again. This dialog box shows up. Here I put, for value, I put 0. And that refers to female. And then click add. And then 1 male. And then click add. and then click OK. So you have this shows up in the value. Actually here, if I double click and then for the gender, you see I have F equal female, M equal male. And then you can say cancel or double click here. You have 0 female, 1 male. Cancel. So again, this is a dummy variable. All right, sex is dummy variable. Now, if go back to the data view, you see, it looks very good, nice. You have all the 1 or 0. 1 is for male and 0 for female. Now, in order to have that run one regression and find the regression equation for male and female, we need another term, and that term is a regression, is an interaction between age and sex. Interaction between that continuous variable age and this dummy variable sex. The reason for that, if you go to the notes here, I write that single equation model. This is a single equation model we're talking about. In that model, in that equation model, you see Y stands for systolic blood pressure. So here EY means average systolic blood pressure equals that constant. And then this is age. X1 stands for age, and this is a slope for the age. And X2 stands for sex. X2 is a dummy variable, has only value of the 1 or 0. And then you have X1, X2, which is the interaction. It's the product of the two is interaction. And then this is the coefficient of that interaction. Now, by just looking at this equation, I can come up with the two equations, separate equation, one for male and one for female, as long as I insert the value of that dummy variable into equation twice, one for female, the other time for male. So here I show you that. Here if x equals 0, if x2 equals 0, you see x2 is a dummy variable, is 0. If it's 0, you see this part is beta 2 x2 or b2 x2 or beta 3 x1 x2 would go away. Okay, because these are become 0. So that's the equation. Here, this is the equation, we call it regression equation for female. Now, if I put x2 equals 1, so I have beta 0 plus beta 2, because this is 1. So I just put them together as a constant. And then we have beta 1 x1 and beta 3 x1. Remember, x2 becomes 1. So again, I factor it like that. I put the x1 and beta 1, beta 3. So this equation, regression equation for male. Here there are three scenarios we can talk about. One, if the two lines are parallel. Parallel means the rate of change in blood pressure between male and female are the same. In other words, their blood pressure goes the same rate. So if this is the case, so this beta 3 should be 0 because they should have the same slope. Beta 1 x1 should be beta 1 x1. So the two lines are parallel when they have the same slope or equal slope. So again, what is beta 3? Beta 3 is the coefficient of this interaction. So in other words, there should not be any interaction between age and gender in order to achieve that. Now, if the two lines start at the same point, in other words, the constant are the same, the intercept is the same, so this beta 2 should be 0. Beta 2 should be 0. Or if the two lines are coincident or coincide, means beta 2 and beta 3 should be 0. In other words, all the two lines becomes like that. Two lines become beta 0 plus b1 x1. So b2 and beta 2 should be 0. In other words, in blood, when it comes to blood pressure study, gender has no effect on that. Only age is a factor, something like that. Okay, that's a single equation model. And through this single equation model, we can separate the two lines. Let's do this empirically by the number. So go back to the SPSS data set. So we have to generate another variable here, and we call this variable interaction between age and sex. And here I click on analyze, not analyze, I'm sorry, click on transform, and then compute variable. And this time I have to come up with a new name for that interaction. In the note I have int, but a better name is age sex. Okay, like that, age sex. So I click on age. You see it goes to the right, move it to the right. And then I click on this asterisk here, which is time. And then highlight sex and move it to the right. So the product of these two variables makes an interaction. That's the way we define interaction in regression. And then I click OK. Then see a new column shows up here. So for for male subjects, you have numbers because you see 41 times 1 is 41, 60 times 1 is 60. But for female, everything is 0. Every entry in that column is 0 because that dummy variable is 0. So in other words, 39 times 0 is 0, 45 times 0, 0, and so forth. Again, I don't need that 2 decimals, and I like to move the data to the right and find out what type of variable it is. So I just click on variable view, and here I move the decimal to 0 and put this variable in the center and leave it the way it is as a scale. It's a scale is fine, it's a continuous. So I go back to the data view. You see you have that very good looking interaction column here. Now I'm ready to run that multiple regression equation. Consists of systolic blood pressure as a dependent variable, age, sex, and this interaction as independent variable. So I click on analyze, and this time I click on regression, linear. So systolic blood pressure is fine as a dependent variable. Age is as independent variable is fine. I move sex and interaction also as other independent variables. So we have 3 independent variables here. I have to remove that selection variable. So highlight that and click on that arrow, it's gone. So I'm ready to run that multiple regression by clicking on that OK. And that gives me the output. Again, I'm going to delete these, only concentrate on the coefficient table. Okay, in that coefficient table, you see we have the age, sex, and then interaction between the two. And as you see here, age is significant, and gender is not almost significant. Is not. If it's 0.05 or less, would be significant, and the interaction is not significant at all. So in other words, that 1 point difference in the slope between male and female is not statistically significant. So in other words, we can say the rate of increase in blood pressure between male and female are almost the same. All right. So that's the idea here in this equation. Or you can say the 2 lines are parallel or almost parallel because this interaction, this is beta 3 or B3 is practically 0. Okay, if you look at the notes, you see I ran this regression, exactly the same thing here. This is that I just put it in the notes here. And this is the regression equation. You see you have the systolic blood pressure, estimate of systolic blood pressure, intercept. This is the slope for age. And then the coefficient for sex, and then INT here is interaction. And I call it age sex, but INT interaction here. So which is age and sex here, just I put that. So the age times sex. Now, if I use that systolic blood pressure as a y, and then x1 is age, and x2 is sex, which is a dummy variable, 1 if it's a male, 0 if it's female, and I come up with this equation. You see, this is the equation. This is an estimate of single equation model. We estimated value for each of these betas, beta 0, beta 1, beta 2, beta 3. Now, based on that, I come up with the 2 equations, one for male and one for female. As long as I insert the value of x2, which is 0, 1, and I can achieve that. Here I show you that. Here is, you see, if x2 equals 0, which means referring to female, this is the equation. Every time I see x2, I just plug a 0 there, 0, 0. So again, this part, this 129061 times 0, and this part, well, these two will go away because they have a 0 component, so these become 0. So again, you see you have that equation. That's the estimated equation for female. And then if I put 1 for x2, remember x2 is dummy variable. So here we have the constant. x1 is already age, is fine. You see, I put the 1 here and then 1 hit there. So this becomes 12.961. So I add this 97 and this 12 together, I get 110. And then 94.9 and this 0.012 together, I get 0.964. And these are exactly the same equation we found in the beginning of the lecture by SPSS twice. I was able to generate these two equations by just using a dummy variable, using gender as a dummy variable, and this two equation is a result of these two equations. Now, go back to the SPSS. I'm going to talk a little bit about the dummy variable and the characteristic of dummy variable. Here, if you look at the output in that SPSS, you see this is the multiple regression. This 12.96 actually always the standardized coefficient of the dummy variable, that unstandardized coefficient of dummy variable, is a difference in outcome variable between the two groups. The outcome variable here in this example is systolic blood pressure. This is a difference in systolic blood pressure between male and female. When the age is controlled, when the age and this interaction is controlled for, all right? So we have that number. So this is the, again, difference in systolic blood pressure between male and female when we control for age. Now, I can give you also, look at the systolic blood pressure. We already have the systolic blood pressure in our data set. Okay, go back to the data set. We have the systolic blood pressure. We have this group, male and female. We can calculate what is the mean of systolic blood pressure for male, what is the mean of systolic blood pressure for female, and is there a difference between the two means? You see, we have that systolic blood pressure, and we have this category 0, 1. So this is an example of t-test. It's a two-sample t-test. So I run that. I click on Analyze, Compare Means, Independent Sample t-test. I move the systolic blood pressure as a variable, as a test variable. Sex goes to grouping variable. So you have two question marks. I have to take care of those two question marks. So I click on Define. I know I have one value 0, one value 1. This is the dummy variable x2, or we call it sex here. So I click Continue. You see I have 0, 1 there, and I click OK. And that's give us a SPSS output. As you see here, you see the mean systolic blood pressure for female is 139, almost 140. And then for male is 155. So there is a 15-point difference between the two, which is, you can see here the difference is 15. This is exact difference, 15.288. Now, why over there, as I said, difference? Why is 12 here? Here is 15. The reason is 12 here because that number is adjusted for age. That's the idea in multiple regression. I mentioned that many times. In a multiple regression, we only concentrate on the marginal contribution of each variable, not absolute contribution. Absolute contribution of variable only is possible if there is zero correlation between this variable, which is very rare. In the real world, never happens. So as long as there is some correlation between these variables, their marginal contribution would be way different from the absolute contribution. The more correlation between these variables, the little marginal contribution of each variable. So again, here is 15, 288, but it's 12 here. One other thing is, you see here is that difference is 12, almost 13 point, is not significant. But when you look at the t-test, you see we have a significant, highly significant. In other words, these two differences, this 15-point difference in systolic blood pressure between male and female is highly significant. Now, we can generate, or we can find this exact value using multiple regression. If you move the age out of regression, only run a regression as a systolic blood pressure as a dependent variable and sex as independent variable. and then we will see exact this number shows up. You will see here if I click on analyze and then regression and linear. At this point, I'm going to remove that, actually remove the sex and put the sex back. Only have CC, I have systolic blood pressure as a dependent variable and sex as independent variable. All right. So this is a simple regression, one dependent, one independent variable, and that independent variable is a dummy variable. So, and it's fine as long as it's 0, 1, dummy variable is allowed in the regression. So I click OK. Again, I'm going to, this is for t-test we had. I'm going to get rid of, until I get to the coefficient. Okay, here. This is a regression, and this is a simple regression I was talking about. You see the dependent variable is systolic blood pressure, the independent variable is sex, and look at that coefficient. It's 15,288, exactly the same. The reason it's negative here because the computer in t-test wrote 139 minus 155, so that's why you get negative. But look at the absolute value, exactly the same. So again, if the dummy variable is only variable in your regression, the coefficient, the unstandardized coefficient on that regression for dummy variable is a difference in the mean of that outcome, whatever outcome you're looking for. Here is systolic blood pressure between the two groups. Here, the difference in mean systolic blood pressure between male and female is 15.288, and then represented by that is unstandardized coefficient of this dummy variable. Now, in practice, we rarely use that interaction term in the dummy variable. We use that interaction in order to show you how to find the two lines. But sometimes you don't need to do that. You want to find out how the groups are different based on that response variable. In other words, you want to see how the groups in this example, male and female, are different in terms of their blood pressure. And then you only use one dummy variable here because of gender. And then as you see, this is highly significant. And that t-value is exactly identical to that p-value here, you see. Exactly the same t-value. And then p-value, of course, the same. So again, these are a lot of similarity between the two t-test and the multiple regression if only that independent variable is a dummy variable. So actually, instead of t-test, you can run a simple regression with your response and your group as an independent variable. Okay, that's conclude our lecture on dummy variable at this point.